Hello. Today we're going to do the opposite of what we've been doing in class, and instead of me giving you an equation and you drawing the graph, what I'm going to do is I'm going to give you the graph and you're going to write the equation of that function that's been transformed on that graph. So there's really a 5-step method that you can go through in order to write the correct equation. And the first thing you're going to do, and I'm going to demonstrate this on this worksheet that I gave you in class, so you should have this handy. And as I go through the steps, I'm going to go through the steps on this graph, writing them down here and then demonstrating them here. So the first thing we're going to do is we're going to draw new XY axes. New XY axes. And the vertex, which is the vertex of the transformed function, will be at the origin of the new XY axes. The new XY axes, the new 0, 0. And that's where the vertex of this graph will be. In other words, I'm going to look at this. I know this is a quadratic graph, and here's the vertex up here. So I'm just going to mark the vertex. And then I'm going to draw new XY axes, and this origin is going to be right here at the vertex. So here we go. So here's our XY axes right here, our new ones. This is 0, 0. This would be 1, negative 1, 1, negative 2, etc. All right? That's the first step. That's pretty easy. The second step we're going to do is determine the vertical and horizontal shifts. And we'll write them down. First of all, we'll have a horizontal shift. Usually, well, not always, but sometimes we'll have a horizontal shift. And I'll just write that as HS for horizontal shift. And we'll figure out what that is. Oops, sorry about that bell. Then we'll have a vertical shift. And I'll write that as VS, the vertical shift. So when we look at this graph, we can see that this graph has been shifted to the right 4. So that's our horizontal shift. Horizontal shift is to the right 4, R for right. And when you move something to the right, remember that it's a -4 to the x's that we're going to be doing. Right is minus. And the vertical shift, it looks like it's been moved up 5. So I'll just say U5 for up 5. And that means we're going to be adding 5 to the y's. So remember, y minus 5 and x minus 4 will be those shifts. So that's the second step. The third step is what you're going to do is you're going to find a point on the graph that's the closest to the vertex. Where a definite xy value can be determined. So in other words, it's not a half or a third. It's right on a point, an integer value of points. And instead of xy, I'm going to call them AB, because really they're the new xy's from our new xy axis. So we're definite AB values, and I'll show you what that means in a second, can be found from the new xy axes. So what I mean by that is you're going to take this graph and you're going to take a look and say, oh, what can I see? I can see that this point right here is a definite point on this graph that originally it would be at 5, 2, but we're not going to call this 5, 2 anymore because here's our xy axis. So this is actually 1, negative 3. So let's call this 1, -3 based on our new xy axes. And so that 1, -3 is equal to our a comma b that I'm talking about in step 3. Then we're all set to write the equation of a function based on the shifts and the new point that we found. And this is how we're going to do it. Write equation of function like this. You're going to start out with y equals, and then whatever this b value you found will go on the outside of parentheses, because remember, on the outside means what we're doing to the y values. And then on the inside of the parentheses, you're going to have 1 over a. Remember, a is the x value, and whatever you do to the x's, it's the opposite. So 1 over a. Watch this, open up parentheses, and then you're going to do x plus the horizontal shift, or minus, whatever it is, and I'll just put HS in there for horizontal shift. Close up this set of parentheses. Close up this set of parentheses. Remember, we've got two of them. And then on the outside, this is going to be squared or cubed, or maybe we'll do a square root function or absolute value. Whatever the parent function is, it'll go right there. And then we'll do plus the vertical shift, or minus if it's gone down. So this is kind of the important part, and it's a wrap-up of the whole thing. And what does that mean? I'm going to show you in each one of these examples what that means. So in this case, let's just write the shell of this. Y is equal to b times 1 over a, parentheses, x plus a horizontal shift. And then this is a squared function or a quadratic function, so we'll put 2 there, and then plus the vertical shift. Well, remember, our b value is -3, so y is equal to -3, parentheses, 1 over a. A is 1, so 1 over a is just 1 over 1, and we don't even have to write that. And then we'll have x. Now the horizontal shift, remember, this has been shifted to the right. Right is minus, right 4, parentheses, squared, and the vertical shift was 5. So we can clean this up a little bit because we don't really need the 1 over 1, and that means we really don't need this double set of parentheses right here because we didn't really have to horizontally stretch this at all. So y is equal to -3 times x minus 4 squared plus 5 should be the equation. And that leads us to our last step, which is check on the graphing calculator to make sure it matches. Check with the graphing calculator. Of course, when you get to a quiz or a test, I'm not going to allow this, but in the beginning when you're just practicing this, it's a good idea. So let's take a look at this inside here. -3, parentheses, x minus 4 squared plus 5. Take a look at the graph. Looks like what I gave you on the worksheet. They look pretty much the same, and you can take a look at the table of values, and our table of values had 4, 5 on it. Yep, there's 4, 5. It also had a 3, 2 on it and a 5, 2 on it, and all of those values here are on the original graph that I gave you, so we're all set. That means it checks. Okay, so let's go through all of these other ones in a similar fashion, going through those 5 steps. The first thing we're going to do is we're going to locate our vertex here, draw our new xy axes. Our horizontal shift, looks like we've gone to the right by 3, and it looks like the vertical shift, looks like we've gone down 4. So remember, right would be x minus 3, and then down would be y minus 4, or a minus 4 at the very end. Now let's see if we can find a definite point on this graph. Well, it looks like right here, this point is our first one, and based on our new xy axes, our new xy axis says that this point is over 1, up 1, 2, 3, 4. So 1 comma 4 would equal our a comma b value. And then we're all set to write the equation. Y is equal to b, which is 4, times, now we've got 1 over 1 again, so I'm not going to write that. I'm just going to write, oh, this is an absolute value, so I guess I'll just put the absolute value bars on this, and this would be x minus 3 absolute value, and it's been moved down 4, so minus 4. So there, it looks like that would be our equation, and let's check this out. Y equals 4 alpha window option 1 absolute value of x minus 3 and then minus 4. See if that matches. Kind of looks like it. Looks like it goes to the x-axis at 2, 0 and 4, 0, and our vertex was 3, negative 4. Yep. So our table matches, so we're in good shape. Our next one is a cubic function. So the vertex of a cubic function looks like it's right here, where it flattens out. Our new xy axes. Right here. So it looks like this horizontal shift has been moved to the right 4. So HS, we'll say this has gone to the right 4, which means it's going to be x minus 4. The vertical shift, it looks like it's been moved up 2, so y plus 2, or plus 2 at the end of the function. I'll zoom in a little bit so you can see this better. And now let's find a definite point on this graph. See, it's kind of hard to see, but I think this point right here would be a definite point. So we're going over 1, 2, 3, up 1, 2, 3, 4, 5. So over 3 and up 5 from the new xy axis would be our a comma b values. And now we have everything we need to write this cubic function. Y is equal to b, which is 5, parentheses 1 over a, which is 1 over 3, times x minus 4. Okay, and now remember we have to double up our parentheses and cube that. Remember this double parentheses. If you don't double it up, it's not going to be the right one. And then, like I said, we're going to move it up 2, so plus 2 is at the end. So that would be our final answer. Let's make sure we're right. Y equals 5, parentheses 1/3, parentheses x minus 4 to the 3rd power plus 2. Let's take a look at that graph. Make sure it's in the right quadrant at least. Yep, that looks pretty good. So 4, 2 would be on this, and 7, 7 looks like it should be on it. There's 4, 2, and there's 7, 7. And then if you wanted to go back and see some other integers, 1, negative 3, over 1 down 3, there's another point on this graph, 1, negative 3. So we're pretty good. This next one is called the greatest integer function. I hope that you studied this last year in Algebra 2. It means the greatest integer that's less than or equal to a particular number. The greatest integer function, the notation is this. It's like a square bracket, but it's got this extra line in it. And all it is a step. It's called the step function also. It's got another name, step function. And this is from the graphing calculator, which doesn't show that there's a filled in circle on the left and an open circle on the right. So you should fill in the circle and open the circle on the right. That's the step function, or the greatest integer function. And I'll show you how to do those on the calculator. There should be one here with an open, and here with an open. So to the left is filled in, to the right is open. All right, so this greatest integer function, let me show you on the graphing calculator how you get that. You're going to hit Math, and then go over to Num, and down to the option 5 int, that is the greatest integer function. And if you just do a greatest integer of x and hit the graph button, you can see those stair steps going. Each one of these steps has a length of 1, and the distance between each one is 1. That's just an untransformed step function. Now what's happened to this one is it's been vertically stretched by 2, because a horizontal stretch would mean these lines would be longer, but these lines are all just 1 long, so the horizontal stretch, there isn't 1. The vertical stretch is 2. So we'll just write that down. Vertical, this is done a little bit differently than the other ones. And the horizontal stretch, there is none. And then normally a greatest integer function starts at the origin, 0, 0. So what's happened to this function, like I said, it usually starts at 0, 0 with the filled in circle, and it goes to the right and has an open circle there. But what's happened to this? Well, you can look at it in 2 different ways. This filled in circle that's usually at the origin has been moved either down 2, you can call it a vertical shift down 2, or you can call it a horizontal shift to the right 1. It doesn't matter, they're the same thing. So let's just say that we'll call this a vertical shift down 2, which is really y minus 2 in the end. And now that we know about the stretches and the shift, we can write the greatest integer function like this. Y is equal to, the vertical stretch is 2, the greatest integer function is like this, x, and then this has been moved down 2, so minus 2 at the end. So let's just transform this function. If you insert a 2, that would be your vertical stretch, and if you did a minus 2, that would make it move down 2. And then the new one should match what we see on our graph, and it does. If you can just take a look at that, they match. The next example we have, or the next couple of examples, it looks like we have a square root function. The vertex here is really the starting point. There should be an arrow here, and over here, here's a starting point. This starting point actually is way down here. And so now let's draw our xy axis. The vertex is really, like I said, the starting point, so we'll just draw our new xy axes right here. We'll see about the shifts. So this horizontal shift, it looks like it's going to the left 2, which would mean x plus 2. And it looks like it's been moved up 3, the vertical shift, up 3, so y plus 3. And now let's find a definite point on this graph. Oh, it looks like this one right here. It looks like it has a y-intercept of 4. But this AB value is over 2 and up 1. So 2, 1 would be the AB value. And that's all we need to write this square root function now. Y is equal to, remember the b comes first, well this b value is 1, so we really don't have to write it. So now we can do the square root function. The a value is 1, so we're going to do 1 over a, which is 1 over 2. And then we're going to have to open up the parentheses, remember, and the horizontal shift would be x plus 2. And then outside the square root function is a plus 3 because it's been moved up 3. Now, you don't have to, and I wouldn't, you don't have to distribute this 1/2. Just leave it like that, because then we can see the transformations a lot easier if you just leave it. So let's take a look at this square root function of 1/2 parentheses x plus 2, and then outside we have a plus 3. and it looks like it's going through the y-axis at 4, and it looks like it has a point -2, 3 on it. Let's see. Yep, -2, 3 is the start, and there's our y-intercept, and we can take a look at maybe there's another one. 6, 5 would also be on that graph. Okay, here's the next one. Sorry, this is going a little bit long with all my explanations. Let's go a little faster here. Here's our new xy axes. And it looks like our horizontal shift left 4, which would mean x plus 4. Vertical shift looks like it's going down 5, which would mean y minus 5. I hope I don't make a mistake because I'm kind of going fast here. It looks like this point here, a comma b, is over 1 up 3. So we can say y is equal to b, which is on the outside of the function. This is a square root function. We don't have to do 1 over a because a is just 1. So then we can just put an x plus 4 and then minus 5 on the outside. And if you want to check that in your calculator, I think you can see, you can do this yourself, but that will check. Here's our next one. This is an absolute value function. Here's our new xy. Anytime you want to shut off the video and try these on your own, be my guest. Okay, so this horizontal shift, it looks like it's been moved to the right, 3. The vertical shift, it looks like it's been moved up, 2. And a right 3 would be x minus 3. Up 2 would be, whoops, 1, 2, 3, would be y plus 2. And then let's find a definite point. Right here would be our a, b value, over 3, down 1. So a comma b is over 3, down 1. And now we can write our function. Y is equal to -1. If you want to write the 1, you don't have, you can, but you don't have to. -1 times the absolute value of 1 over a. A is 1 over 3 times x minus 3, absolute value, and then a plus 2 at the end. And you can check that in your calculator. I think that would check out. And then the last one is just a linear function. So let's use the point slope formula on this. Here's a point on the graph. You don't want to get the y-intercept. You don't know what that y-intercept is. But here's a point on the graph. That point is 1, 0. Let's get another point on this graph. Oh, here's another point, 6, 3. So we've got 2 points on the graph, and if you remember from last week's video, you need 2 points to determine the slope. Slope is equal to y1 minus y2 over x1 minus x2, or the other way around. 6 minus 1 is 5. So this has a slope of a rise of 3 and a run of 5. And now the point slope formula, it doesn't matter which point we use. Let's use this for our point because I like it when there are zeros. Remember, the point slope formula goes y minus y1 is equal to m times x minus x1, and it doesn't matter what point you use. So we'll use this point. So y minus y1 is 0. The slope is 3/5. X minus x1 is 1. So you can leave it like that if you want, or you can just take that minus 0 out if you want. If you want to distribute the 3/5, you can. Really doesn't matter. Knock yourself out and do anything algebraically as long as it's correct. But I'll just leave it like that. So that's the end of the video. Have a nice night.